On the left-hand side we have hydrochloric acid with an electrostatic potential map, and on the right-hand side we have chlorine with an electrostatic potential map. The red part of the electrostatic potential map is electron-rich, the blue is electron-poor, and the green is neutral. Here we are looking molecules that have covalent bonds since the electrons are shared between the two atoms. In ionic bonds it is not about sharing but transfer of electrons from the one atom to the other. Both the hydrochloric acid and chlorine molecules are covalent, but they are different. In the case of the hydrochloric acid, the electrons forming the bond are not equally shared between the two atoms, but the chlorine side is more electron-rich than the hydrogen side since the chlorine ion is more electronegative than hydrogen. The bond between the hydrogen and chlorine is polar covalent. In the case of the chlorine molecule, the electrons forming the bonds are equally shared between the two chlorine atoms since their electronegativities are the same. The bond between the two chlorine atoms are nonpolar covalent. A covalent bond is forming between the hydrogen and chlorine since the electrons are shared between the two atoms. The electronegativity of the chlorine is much higher than the hydrogen, therefore the sharing of the electrons in the bond is not equal. This non-equal sharing of electrons give rise to a polar covalent bond. A covalent bond is forming between the chlorine and chlorine atoms since the electrons are shared between the two atoms. The electronegativity of the two chlorines are equal, and thus the sharing of the electrons in the bond is equal. This equal sharing of electrons give rise to a non-polar covalent bond.